Good day everyone. Computer Architecture Problem-Based Assignment Topic 4.0 presented by Supakim, daughter of Devasigamani
and Ritika.
And my name is Muhammad Faris bin Rahman.
Question 1, Roman 1. Define addressing mode. The method a processor uses to locate or access the operand.
This is all the addressing node in M68000 processor. First, data register direct addressing. After that, address register direct addressing, absolute sort addressing, absolute long addressing, process counter relative addressing, register indirect addressing, post increment register indirect addressing, pre-decrement register indirect addressing, register indirect with offset addressing, index register indirect with offset addressing, immediate data addressing, and lastly, implied register addressing.
Roman 3. Examples of a M68K assembly program that performs addition of two numbers using at least three addresses. Let's go through this addition program step by step. First, the directive origin $1000 tells the assembler to start placing the code at memory address 1000 hexadecimal. Next, move.w D0 and D1 copies the contents of register D0 into register D1. Then, move.w #3000 and D2 loads the immediate value 3000 hexadecimal into the register D2. After that, add.w D1 and D2 performs the addition and it adds the value in D1 to D2 and stores the result back into D2. Once the addition is done, move.w D2 $4000 moves the final result into the memory location for 4000 hexadecimal. Finally, simhalt stops the program execution and endstart marks the end of the source code. So overall, this program adds the contents of D0 and 3000 hexadecimal, then stores the result in memory at address 4000 hexadecimal. Roman 4. Give examples a M68K assembly program that performs subtraction of two numbers using at least three addressing mode. Now, let's look at the subtraction program. It starts with origin $1000, which tells the assembler to begin placing the program at memory address 1000 hexadecimal. Then, move.w D0 and D1 copies the data from register D0 into register D1. Next, move.w #3000 and D2 loads the constant value 3000 hexadecimal into register D2. After that, sub.w D1 and D2 performs the subtraction. It subtracts the value in D1 from D2 and stores the result back into D2. Once the subtraction is complete, move.w D2 $4000 stores the final result in memory location 4000 hexadecimal. Then, simhalt stops the program execution and finally endstart marks the end of the program. So overall, this program subtracts the value in D1 from 3000 hexadecimal and saves the result in memory at address 4000 hexadecimal.
Okay, so now let's move on to question 1b, which is to describe every step of the assembly language of figure 1 using EZ68 simulator. So, first of all, the program starts at memory address $2000. So, and then it moves the hexadecimal value, which is 4AB7, into the data register D1. Later on, it performs a bitwise NOT operation on the contents of D1. And then it moves the immediate value 5E92 into data register D3. And it performs a logical OR between D2 and D3. Later on, it adds the content of D2 into D3 and then it subtracts the value in D2 from D3. Later on, it marks the end of the assembly program. That's all. Let's move on to question B2, which would be list all logical and arithmetic instruction in M68K assembly language. So, moving on to the logical instructions first, there are 5 which would be logical AND or exclusive OR, logical NOT and also clear operand. Next, let's move on to arithmetic instruction. Add I, which would be add immediate, sub, which would be addition, which means subtraction, sub I, subtract immediate, and then MULS, which would be multiply sign, and then MULU, which would be multiply unsigned, and then DIVS, which would be divide signed, and then DIVU, which would be divide unsigned, and NEG, which would be negate, which would be change the sign.
Convert expression into assembly language instruction. Open bracket 101111112 times DADA 16 close bracket plus 12348. Move .w hashtag $BF comma D0 semicolon load 1011111 base 2 into D0. Then move .w hashtag $DADA comma D1 semicolon load DADA base 16 into D1. After that, mulu D1 comma D0 semicolon multiply D0 times D1. Lastly, add .w hashtag $22C comma D0 semicolon add 1234 base 8 in hex $29C to result.